Today, we are going to talk about graphing sine and cosine functions. When we graph sine and cosine functions on the Cartesian plane, instead of graphing on the points 1, 2, 3, 4, etc., we use some different points from the unit circle. In order to see where these points come from, you can trace the unit circle and then make a point on each of those key angles. Now that we have traced the unit circle and made points on our key angles, we're going to take that unit circle and move it over to 0, 0 on our Cartesian plane. Then what we can do is we can roll that circle across the x-axis. And as we do, those key points that we chose are going to come off along the x-axis, spaced out the right angle measures. Now we are going to label those key points with the angles that they came from. And so we're going to do that in radians. So each of these key points came from a radian measure on the unit circle. Now that we have done this, we are ready to start thinking about our graph of sine. That looks like y equals sine of theta, and sometimes you'll see y equals sine of x. Theta and x are both just variables. One is Greek and one is Arabic. Somewhere along the lines, mathematicians decided that Greek letters should be used for angles, but sometimes we use x because that's what we see most often. Think back to when you did triangle trig. When you have an angle on the unit circle, you can make a triangle out of it. Remember, the sine ratio is opposite over hypotenuse, depending on where theta is. In this case, this would be the opposite side, and this would be the hypotenuse. Because we're working with the unit circle, by definition, the radius is always 1. And that means the hypotenuse is always going to be 1. So we can think of the sine of an angle on the unit circle as opposite over 1, or just the opposite. If we were to think about where that would fall on the triangle, that would be the height of the triangle. So the sine of an angle is equal to the height of the triangle. Remember how we've labeled coordinates on our unit circle, and that height will come from the y-coordinate. So anytime you're trying to find the sine of an angle, we are going to look at the y-coordinate. So let's come back to our graph. We are going to graph the y-coordinates or the heights at these key angles, and we are going to look for a pattern. So at 0 radians, the height is 0. There's nothing we can put there, so I'm just going to label it with a 0. At pi over 6, if we have a triangle, there is a height there of 1/2, so we can take that height, transfer it over to our graph, and label it with a height of 1/2. Now pi over 4, we can take that height of root 2 over 2, bring it over to our graph, and label it. Pi over 3, we can bring that over to our graph, label it, and we can keep going around the circle in that manner. Now when we get to pi, that has a height of 0. There's no triangle there, so I'm just going to label it with a 0. But now notice our new y-coordinate is negative. So when we transfer it over to our graph, it's going to be below the x-axis, and we'll label it negative 1/2. And we're going to keep going around like that. And finally, at 2 pi, we have a height of 0. So these are the key points on y equals sine of theta. And they help us see a pattern. What if we could graph every single angle in between the ones that we chose to graph? Well, we would get a wave that looks like this. Please notice that there's arrows on the end of the wave. That's because we could go around the circle again and again and again, and that wave would repeat itself. So there's some key points that you need to remember from this. You don't have to remember all the ones on the unit circle, but I want you to remember intersections with the x-axis and then local maximum and minimum. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So this is the graph of y equals sine of theta. Now we're going to look at the graph of y equals cosine of theta. Sometimes we'll see that as y equals cosine of x. Remember, we're going to return to our unit circle. If we've got an angle on the unit circle, we can make a triangle out of it. And in the case of cosine, that's adjacent over hypotenuse. So here's the adjacent side and the hypotenuse. Remember that since a unit circle has a radius of 1, the hypotenuse is going to equal 1. So we can think of cosine as a over 1 or just a. So a in this case is the width of the triangle. So when we find the cosine of an angle, we can think about the width of a triangle. And if we're looking at the coordinate, we can look at the x-coordinate. So going back to our graph, at 0 radians, the x-coordinate is 1. But because our measurement is horizontal, we are going to rotate it and make it vertical when we bring it over to our graph and label it with a height of 1. Same thing here, we have a measurement of root 3 over 2. We're going to rotate it and label it. We're going to go around the circle just like we did before. Now, here, notice we have a height of 0. And then our next coordinate, the x value is negative 1/2. So because we're in the negatives, we're going to put our measurements below the x-axis on our graph. And we're going to keep going like that and keep labeling. Notice the x values are still negative all throughout here. Now we're back to an x value of 0, and then the x values become positive again, so they're going to pop back up above the x-axis. So again, this was enough to help us see a pattern of what cosine of our key angles look like. But if we were to do every angle in between, we would get a wave that looks like this. So this is the cosine wave. And there's some key points to remember on that cosine wave. The local max and mins, and then the x-intercepts. So 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. So now it's time for some vocabulary to help us talk about the new graphs that you just learned about. The first vocabulary term we're going to talk about is the period of a function. And the period of a function is the length of one full cycle. We went around the circle one time, but remember, we could keep going forever. One way you can think about it is when you do a single sine or cosine wave, it's kind of like a stamp. And you could pick up that stamp and make another stamp and continue that wave forever and ever. But when we talk about the period, we are just talking about a single cycle. So the period of y equals sine of theta is 2 pi because we are just talking about that original cycle that's right here. So it's your job to find the period of each graph. So you are looking for how long does it take a graph to complete a full cycle. Remember, it has to go above and below the x-axis. Sometimes students will say, okay, I'm starting on the x-axis, so right here must be a full cycle because I'm back at the x-axis. Not quite, because you have to go above and below. So we're going to go above and below, and here we've made a full cycle. So the period of this first function is pi. We're going to use p to denote period. This second function starts at the maximum, and we want a full cycle. So when does it return to the maximum after a full wave above and below? So it makes a full wave above. It's split in parts but this is a full wave above, and then this is a full wave below. So the period here is going to be 3 pi. And then finally down here, it starts at the origin, but remember, we don't just want to return to an origin, we want a full cycle. So you got to go above and below. So the period of this is going to be halfway between pi and 2 pi. So the period will be 1.5 pi, or you can think of that as 3 pi over 2. So the amplitude of a sine or cosine graph is the distance from the midline to the maximum. Sometimes students will look at this and say, okay, here's the minimum, here's the maximum, so the height of this guy must be 2. But when you are measuring the amplitude, you are not measuring from the bottom to the top. You are measuring from the midline to the top. And so I think of the midline as sea level. We've got that mountain, which is above, and we've got the ocean, which is below. So when you measure the amplitude, you measure from sea level. So the amplitude of this wave is going to be 1, because that's the height from the midline, or from sea level to the maximum. Now, sometimes your sea level will move up and down. That doesn't change the amplitude at all. Sometimes your midline could be way up here, but notice the mountain and the sea are the same height. Your midline could be way down here. Again, mountain and sea are the same height. You always measure from the midline to the maximum. So let's look at some examples. It's your job to find the amplitude of each graph. And in order to do that, you have to find where the midline is. If you have trouble finding the midline, a good thing to do is find the minimum, the maximum, and their distance. So the distance between the minimum and the maximum is 1, 2, 3, 4. So halfway between 4 is right here, 2 above and 2 below. So then if you sketch your midline, it comes out right here. Now we can measure the distance from the midline to the maximum. So this is going to be 2. And we call that the amplitude, so A equals 2. For this next one, the midline is right here. And we're going to measure the distance from the midline to the maximum. So even though this isn't labeled, we could use the fact that this is negative 16 to discern that this would be positive 16. So the amplitude is going to be 16. And then here, all we know is that this is 5. But the midline is halfway between 0 and 5, so it's going to be here at 2.5. So when you measure the amplitude, it'll be from here to here, so 2.5. So A equals 2.5. The amplitude is always positive, because you are measuring the height of something. Even if a graph starts out negative, like this, you are still measuring something. And when you measure something, it's always positive, even if it's below the ocean. You never say that that the pool was negative 12 feet deep. You just say 12 feet deep. So always positive. So let's do a quick recap of sine and cosine graphs and their characteristics, and then we'll look at some examples from equations. Sine and cosine graphs are different because sine starts at 0 and cosine starts at 1, or the maximum. What they have in common is they both have a period of 2 pi. That's one full cycle. And that should make sense because we went around the circle, which has a measure of 2 pi radians. Both graphs also have an amplitude of 1. And since they came from the unit circle, which has a radius of 1, that makes sense that that's the biggest they could get. So here are the functions y equals sine of theta and y equals cosine of theta, but now they have some transformations in them. There's two things here. First of all, the amplitude of the graph can be found from the equation where A is. That number out in front is going to tell us the amplitude of a graph. The period of a graph doesn't come directly from the equation, but what we do is to find the period, we do 2 pi over b. So b is the value here and here. B has a special name called frequency, and that means how many circles show up in a 2 pi span. So far, our frequencies have been 1 because we've been doing 1 circle in a 2 pi span. So in order to find the period, we do 2 pi divided by b, which is the frequency. So let's look at some examples. We're going to determine the period and the amplitude of each trig function. In order to find the period, we do 2 pi over the b value. So here the period is going to be 2 pi over the b value. The frequency, in this case, is 2. And that reduces to pi. Here the period is going to be 2 pi over the frequency. Again, frequency is in front of the theta. That does not reduce. We're good to go. Here the period is equal to 2 pi over the frequency. This does reduce. We're going to get pi over 3. And then this last one, the period is 2 pi over the frequency, and that reduces to 2. So that tells us the length of a single cycle of your wave that you'll graph from these equations. Now let's look at the amplitude. The amplitude, again, comes from the number in front. And the one thing that you have to be careful of is amplitude is always positive because it's a measurement of height. So here A is 7. Here A is positive 8. Be careful there. Here A is 1/4. And here A is, if there's not a number there, you can assume it's 1. Finally, let's look at graphing these. This might seem kind of scary, but this is actually one of the easier things to do. And the reason why is you can make your wave first and then label it. So let's start by finding the period and the amplitude. The period is 2 pi over the frequency, and that reduces to pi over 2. So that means our wave is going to have a width of pi over 2. Then our amplitude is the number out in front, so that's 2/3. The next thing we need to know is what kind of wave are we going to sketch? And since we have a cosine wave here, that means that we know that our wave is going to start at the maximum. Remember, sine wave starts at the origin, cosine wave starts at the maximum. So we're going to make a cosine wave like this. We know the amplitude is 2/3, so we are going to label the maximum 2/3 and the minimum -2/3. So that part is good to go. Then we know the period is pi over 2. That's the width of a single cycle. So this is going to be pi over 2. So we can label the halfway point if we want to. That's going to be pi over 4. That's halfway there. And then the last thing we're going to do is put arrows on the end of our graph because we know that these are cyclical. They go on forever. So you could technically keep going forever and ever and ever, but you don't have to. As long as you do this initial part with the arrows, as long as you show one full period, you're good to go. So again, find the period, find the amplitude, choose your wave type, and label. Here's another one. We're going to find the period, the amplitude, choose our wave type, and label. The period here is going to be 2 pi over, and since there's an imaginary 1 right here, it's just going to be 2 pi. The amplitude, the amplitude is going to be, that A looks crazy, I'm going to leave it though. So the amplitude is going to be 16. So now we are going to make our wave and label it. So a sine wave starts at the origin and it makes a full cycle. Since the amplitude is 16, this is going to have a height of 16 and a minimum at -16. and the period is going to be 2 pi. And if you want to label halfway, pi. And then pretty please make sure you have arrows on the ends of your wave to imply that those cycles are going to continue forever and ever. All right, let's try one more. I think I accidentally skipped this one, so we're coming back to example 2. We've got a period of 2 pi over 2, so that's pi. And we've got an amplitude of 5. So since we have a sine wave, we start at the origin. We're going to go like that. Our amplitude is 5, so maximum at 5, minimum at -5. And then since our period is pi, we're going to label a full cycle. Halfway there is pi over 2. And don't forget to put arrows on the end to imply that they go on forever.